Welcome to today's session. In this session, we'll continue from the previous class in which we have considered a mode 1 operation of a timer and set of steps we have given to calculate a time interval for a particular wave signal. Okay. Now here in this example, we will calculate the total duration. A total time cycle will be consumed by the program. Okay, these are the program what we have taken it. The very first instruction, that is the lower byte of timer, will be loaded with the immediate value. Second instruction, higher byte will be loaded with the immediate data. Complementary means ones and zeros, and the delay will be called, and SJMP here means it will be keep on looping it. Okay, now if you want to calculate, okay, the total time duration of the program, in the right side I guess I have mentioned with cycles, and previous classes I had given with the appendix in which, okay, these are the cycles will be given by the manufacturer for a particular instruction. Okay, when I sum up this, okay, the each line instruction and its corresponding cycles, when I sum up, it will take a total 28 cycles for execution. Okay, means now this is a program to generate a square wave like this. Okay, now square wave like this. Okay, that is a high and the low. Okay, that will be obtained from 1.5. That's a port 1. There is a 6 bit. Okay, it is the bit will be getting complemented every time, and we are keep on getting the output will be in the form of a square wave. Okay, as we know, when I want to calculate the time duration of the program, okay, so there is an equation we have previously seen, TINS, okay, is equal to, that is C into 12 divided by frequency. Okay, now we considered this frequency will be 11.0592 frequency, that's a megahertz, that is 11.0592 megahertz. Now if I substitute the values, okay, now C will be total cycles consumed by the program. Okay, how much it will be now? 28. Okay, I hope I mentioned here. Okay, now 12 will be means one machine cycle is nothing but 12 clocks. So 12, what is the frequency? 11.092 megahertz. So it will be 1.085 microsecond. That is 12 divided by 11.0592. If I take the operation of this one, it will come with a 1.085 microsecond. And as we know, this program will be repeated for twice in the sense I have to calculate for the full cycle, that is for high as well as for low, means I have to multiply with the 2. Since I get a result 60.76 microsecond, means the total duration of this program, not the time delay of this program, the total duration of the program will be 16452.2 hertz. That is 16 kilohertz of a frequency will be consumed for executing this particular program. Okay, it is for the program, not the time delay. Okay, I hope the program will be clear. Okay, let us move to the next slide, in which, okay, this is this previous slide. I took it from the previous class in order to recall your content. Okay, this is the equation to calculate a timing cycle. FF in hexadecimal, if you want to calculate, the maximum value for 16-bit will be like FF, and whatever the data you set in a TL and TH, that will be YYXX plus 1, means the total will be whatever the number you get in a hexadecimal number, okay, into 1.085 microsecond. I hope you get 1.085. Why I am going to be standard. Sometime it may change. If the frequency will be given with a different, you don't consider the 1.085. You all the way you have to calculate. What is that calculation? That is, you need to be calculate with the 12 will be fixed. Okay, C will be like a number of cycles. Okay, we are not worrying about this. Okay, now we don't worry about this. That is a frequency. So let us take that. Don't consider the 1.085 is the standard. Okay, if the frequency is 20, then 12 divided by 20. You need to be consider that into multiply that. Okay, I hope you can understand this frequency. Okay, where YYXX, TH and TL, and you'll get the values. Okay, that value means it will be getting multiply. Okay, all the way. Don't try to multiply with the hexadecimal value with the 1.085, because 1.085 is a decimal, and what the value you get obtained is a hexadecimal. Okay, you may not be get a result here. So you, whatever the hexadecimal answer you getting here after subtraction, okay, you convert into decimal. Okay, convert the decimal and multiply by 1.085. I hope you understood this. Okay, similarly, if I want to calculate in decimal, okay, convert that YYXX value of THTL register to get a decimal value. Okay, now I say, okay, it's exactly similar here. Okay, what I done here, sorry for this. Okay, now whatever I am getting here, it is the same here. Means what is the FF? Means for FF, its maximum value will be 65536. 65536 minus. Okay, now YYXX, if the value will be set in TH and TL register, you convert that YYXX into decimal value from your calculator. Okay, once you get the answer, you subtract that. You subtract it, you will obtain, you will end up with like a decimal number. Okay, don't add a 1 here, because there's a when the hexa I took as a 0. Okay, now 65536 is included here. Okay, minus whatever the n decimal. Okay, multiply by 1.085. Okay, I repeat here, either of one technique you follow. Sometime in exam both. Okay, if it is asked with a both, you write a both. Okay, if it is asked with like a, but you will end up with the same answer. That is not, there is a 100% guarantee that. Okay, only the technique will be different here. Okay, now let us move to the one more program. Okay, to find the delay generated by timer 0 in the following code using hexadecimal and decimal method. Okay, I hope this point will be clear for you, because I have mentioned with the hexadecimal and decimal method to calculate the timer period. Because look at this, I have to calculate for the timer period. Okay, not for the program. Okay, now the very first instruction will be complement 2.3. Okay, you need not worry about the program here. Okay, because the program will be same, because what we did here. Okay, now timer 0, I said timer 0. Okay, now all the way I have to operate in mode 1. Okay, if I want to operate in mode 1, the lower bit will be 1 0 0 0. Okay, is when I convert this one, it will be come up with like a 0 1. Okay, that is 1 will be indicated for timer 0, means is the bit will be configured, and all the way we have to use with the tmod register. Okay, now the very important is that I am going to be calculate with the time delay interval of the timer. Look at that, TL0 is loaded with 3E, TH0 is loaded with the B8. You can take any random value. Okay, for you to understand, we have loaded with B8 is in TH0, 3E is in TL0, means all together will be B8 3EH will be loaded into timer. Okay, I hope you understood. You can recall from the previous class, it will start counting from this B8 3E. Next will be B8 3F. Okay, the next will be like a B8 10, like this. Okay, sorry, 40 like this. Okay, now it will be count will be start from this. Okay, now you can imagine that. Okay, I have set of 1 to 100. Okay, now if I ask you to count from 50 to 100. Okay, again from 100, again you have to come to 50 to 100, 50 to 100, like this. This is a circle. What you have to do. Sometime again, if you can change. Now if I change with the 75 to 100, 100 to 75, this process will be keep on repeating. Means what value will be loaded here? 50. Now similarly 75. Similarly here I have loaded with the TL0 will be 3E and TH0 will be B8. Okay, now let us move to the solution here, how I calculated, because this program will be indicated to calculate a time interval of the timer. Okay, Now the maximum value, okay, in the solution, okay, this program will be same, okay, there is no any change here. Set B 2.3 means the timer will be set as we know we have to start the timer, and we have to set B TR0, start the timer 0, set the timer 0 operation here, and we keep on monitor this, okay. Which bit will be monitoring? TF0, because I'm using a timer 0, okay. When it will be set to 1? When B8 3E, it is getting incremented. When it reaches FF, okay, there's a maximum value, that time TF0 will be set to 1, means the loop will be broken. Once the loop is broken, it will go to the next instruction. Which is the next instruction? Clear TR0, means your timer will be getting stopped, okay. And we have to clear that whatever the raised value, the raised bit TF0 has to be reset, TF0, and again clear 2.3, whatever the value will be there, clear 2.3, means if it is 1, it will be okay. If it is 1 is there, that has to be cleared. I have to make it with a 0, okay. So again, where it will be end up here, again jump, look at this, okay, set B, okay. So it will start keep on looping this, okay. Now when I say a solution here, okay, from this diagram, FF minus YY XX plus 1, what is the FF here? Maximum, you can't change it, okay. What is the TH and TL? YY XX, that is B8 3E, okay. Now this is also decimal, plus 1, you add this one, you will end up with the 47C2 in hexadecimal, okay. Now as I told, you can't directly multiply with the 1.085. What I have to do? You convert this 47C2 into decimal from your calculator. You'll come with like a 18370 in decimal value, okay. This value you multiply with the 1.085. By default, if it is not given, okay, you can ask me that there is no frequency will be given, but you consider the 12 megahertz, there is 11.095 megahertz, and the time interval, sorry, you will get with the 19.93145 millisecond, okay. Now there is a one more method, there is one more method, in the sense decimal method, okay. Now simple here, that is nothing to do here. TH to TL will be loaded with B8 3EH, and it's 47166, that is a decimal value. Now instead of FFF, okay, if you convert with this 4FF into decimal from your calculator, you'll get with like a 6, you'll get 65536, okay, 65536, and you convert this B8 3EH, okay, B8, this one, B8 3EH, you'll come with a 4766, means 65536, okay. Now I hope you can see here 65536 minus NN, okay. What is the NN value? 47166. You'll get the same answer, okay. That's what I want to justify you, okay. This means, okay, FF you'll get with like 18370, okay, and we know that there is a frequency will be generating 1.085 microsecond, and once you multiply, you will get with the 19.93145 millisecond, okay. Now there's a one simple cross verification you can do. If you are getting with a different, okay, whichever is the different, okay, you recheck it, because you are not getting a correct answer, okay, means you did a mistake in one of the calculation, okay. It's the meaning of this. I hope this program will be clear for you, okay, so that you can change, okay. Sometime you can work it out by changing the values of TL0 and TH0, so you may get a different timing intervals, okay. Now let us move to the one more example, okay. Modify TL and TH from the previous example to get the largest time interval as much as possible in millisecond, okay. When I say the largest possible time interval, okay, exclude the overhead due to instruction in the loop, okay. This is, we need not be considering any overhead, okay. When I say the largest time interval, okay, Now when I say from where the counter will begins here, 3E B8, up till what value? FF. Again where it will be come back, so B8 3E. Okay, like this it will be keep on. Okay, now instead of this B8 3E, if I set with a 0 0, means I all the way, if I start from 0 0, okay, 0 0 0 0 1 0 2 up to what? FF. After FF, again where it will come? Again it will come to 0 0. Okay, as I given with the example, 50 to 100, again 100, again it will come to 50. If I set with a 75 to 100, 100 to 75. If I set with a 0, from where it will start? 0 to 100, again where it will come back? 0. Okay, I hope this concept will be clear. Means similarly I have loaded, okay, I hope they need not be, it is not required to explain you about the 2 instruction here, because 2.3 clear to port 2, that is a 4th bit. 2.3 mode, okay, we are using timer 0 in mode 1. Okay, TL0, I hope you can look at here, TL0 is loaded with 0, TH0 will be loaded with 0. Set B 2.3, same program, okay, and set B timer will be getting started, and we are keep on monitoring. Okay, how long we are monitoring? Okay, until it raises a 1. When it reaches a 1, when it reaches a maximum value, or when it reaches a maximum value and rolling back, during that time TF0 will be set to 1. Okay, now let us come to the, okay, for calculation part here. Okay, now as we know, there is a simple, says what the equation will be now given for you, okay, to calculate 65536, okay, minus TH and TL value. What are the TH and TL value? 0 0 0 0, means I should get with the 65536. Okay, the total is interval, if I multiply this, you will come with the 17.1065 millisecond time interval. It is a maximum time interval possible. Okay, because you can't go, okay, yeah, I can't start, you there is no facility that you start from the minus 10. There is no facility that minus 100. It is not that minus 100 to 0 0 to again 65536. No, not like this. Okay, that is maximum value it can start, and roll back will be from 0 0. So maximum frequency what I can obtain from 11.0592 chip, okay, that is a timer, is of 71.1065 millisecond. Okay, I hope you understood this one. Okay, because the statement will be same here, what I given here mentioned. Okay, now this is the you just look at the, you can change with the different time intervals, so that you will end up with a different frequency. And what the maximum value will be like 71.1065 millisecond. Okay, I hope this concept will be clear for you. Okay, in coming class we'll see some more example, so that it will be more convinced for you. Thank you.